Hi students, today let us take this question. Let R be the set of points inside a rectangle of sides A and B, AB greater than 1, with two sides along the positive directions of x-axis and y-axis. Let the rectangle be ABCD and let PXY be the point which is inside the rectangle. So this PXY is inside the rectangle. This is x-axis and this is y-axis and this point is 0, 0. Okay. Given this side is A of length A and this side is of length B. Okay. See, you take a perpendicular here and this. So this distance is clearly less than B, correct? But it is more than 0. Similarly, this distance is less than A and more than 0. So the point X is more than 0 and less than, more than 0 and less than A. Similarly, point Y is more than 0 and less than B. Now you check the option. You check the option. First option, R is equal to x comma y, 0 less than or equal to x less than or equal to A, 0 less than or equal to y less than or equal to B. See, this x cannot be 0. Therefore, this option you can discard. Option A can be discarded. Similarly, option B also you can discard because 0 less than or equal to x again. So you can discard option B also. The same thing here also, 0 less than or equal to x. You need not have to check further. So this is not possible. Therefore, this is also discarded. Now check the last one. X comma y, 0 less than x less than A, 0 less than y less than B. So this is the correct option. So the answer is option D, that is R is equal to x comma y, 0 less than x less than A and 0 less than y less than B. Okay, thank you. Hi students, let us take the second question. Let T be the set of all triangles in the Euclidean plane and let A relation R on T be defined as ARB if A is congruent to B for all AB belongs to T, then R is reflexive but not transitive, B transitive but not symmetric, C equivalence relation, D none of these. So let us take two triangles. Let us take two triangles. ABC and DEF. So triangle ABC, triangle DEF. You can take one more triangle PQR. Okay. So if you take triangle ABC, angles ABC and sides ABBC and CA, they are equal to triangle again ABC, angle ABC and ABBCCA. So always triangle ABC is congruent to itself. Congruency means corresponding sides and angles of two triangles must be equal. Then those two triangles are congruent. Therefore, so triangle ABC is congruent to triangle ABC. So this implies R is reflexive. R is reflexive. What do you mean by reflexive? For all A belongs to AA belongs to R. So that satisfies. Second, triangle let triangle ABC is congruent to triangle DEF. Means this side is equal to this angle is equal to this angle is equal to this angle is equal to this. Similarly, this side is equal to this and this side is equal to this and this side is equal to this. So if triangle ABC is congruent to triangle DEF, corresponding sides of ABC and angles of ABC and corresponding sides of DEF, they are equal. Okay. So if triangle ABC is congruent to triangle DEF, the ulta triangle DEF must be congruent to triangle ABC also. This implies you can write triangle DEF is congruent to triangle ABC. Correct? So this is symmetric relation. R is symmetric. What do you mean by symmetric? For all AB belongs to A, for all AB belongs to AB belongs to ARB implies PRA. The ulta must be satisfied. So here in this case it's satisfied. Therefore it is R is symmetric. Now take three triangles. Triangle ABC, triangle DEF and triangle PQR. Let triangle ABC, triangle ABC let triangle ABC is congruent to triangle DEF. and triangle TEF is congruent to triangle PQR. Okay. So, corresponding angles of ABC and DEF are equal. Corresponding sides of ABC and DEF are also equal. Similarly, the second sentence meaning corresponding angles of DEF are equal to corresponding angles of PQR, and corresponding sides of DEF are equal to corresponding sides of PQR. So since this is common for both, triangle ABC is congruent to triangle PQR. See, angles of ABC are equal to angles of DEF, and angles of DEF are equal to angles of PQR. That implies angles of ABC must be equals to angles of PQR. Similarly, sides of ABC are equal to sides of PQR. So, the relation R is reflexive, symmetric, and the last one it is transitive also. So, R is reflexive, symmetric, and transitive. If a relation is reflexive, symmetric, and transitive, we call that relation as equivalence relation. Now let us take the option. Option A, reflexive, but not transitive. But we have proved it is transitive. So you can discard option A. You can discard option A. Similarly, transitive but not symmetric. But we have proved it's symmetric also. So this also you can discard. Since R is reflexive, symmetric, and transitive, this is an equivalence relation. Therefore, option C is the correct answer. So, option C, the relation is an equivalence relation. That is the correct answer. Thank you. Hi students, let us take this question now. If a relation R on the set 1, 2, 3 be defined by R is equal to 1, 2, then R is options are A reflexive, B transitive, C symmetric, D none of these. Now, what is reflexive relation? For all A belongs to A, AA belongs to R. Means in this case, the elements are 1, 2, 3. Elements are 1, 2, 3. C. To be reflexive, 1, 1, 2, 2, 3, 3 must be in R. But here, none of these elements are not there. None of the elements are not in R. Therefore, you can write 1, 1 does not belong to R. Therefore, R is not reflexive. R is not reflexive. Next, 1, 2 belongs to R. Given 1, 2 belongs to R. If 2, 1 also, if 2, 1 also there in B, then R is symmetric. But 2, 1 is not there in R. Therefore, R is not symmetric. R is not symmetric. Okay. So, what is the definition of symmetric? AB belongs to R implies BA belongs to R. Here, AB belongs to R, but BA does not belong to R. Therefore, R is not symmetric. Now, C. For transitive, AB belongs to R, BC belongs to R, implies AB belongs to R. Correct? But here we have only one pair. 1, 2 belongs to R. We don't have any other pair. So this only we don't have. So in such cases, we have to consider R as transitive. So therefore R is transitive. It's assumption. R, you have to assume R as transitive because we don't have pair like AB and BC. Now check the options. Option A, R is reflexive. It is not reflexive because 1, 1 does not belong to R. R is transitive. By this, R is transitive. So, R is not symmetric. This last one is not. Therefore, option B, R is transitive, is the correct option. Okay. Thank you. Hi students. Now let us take this question. A is equal to 1, 2, 3 and consider the relation R is equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3. Then see the options. Option A, reflexive but not symmetric. Option B, reflexive but not transitive. Option C, symmetric and transitive. Option D, neither symmetric nor transitive. Okay. So since, see the relation. 1, 1 belongs to R. 2, 2 belongs to R. 3, 3 belongs to R. So for all A belongs to A belongs to R. This is true. Implies R is reflexive. R is reflexive. Okay. Now, see, 1, 2 belongs to 1, 2 is 1, 2. belongs to R. 1, 2 belongs to R, correct? But 2, 1 does not belong to R. 2, 1 does not belong to R. So, what is the definition of symmetric? AB belongs to R implies BA also belong to R. Then R is symmetric. Here 1, 2 belong to R. 1, 2 belongs to R. But 2, 1 does not belong to R. Therefore, R is not symmetric. R is not symmetric. Now consider 1, 2 belongs to R. This 1, 2 belongs to R. 2, 3 belongs to R. Also 1, 3 belongs to R. What's the transitive definition? Transitive definition is AB belongs to R. AB belongs to R. AB belongs to R. BC belongs to R implies AC belongs to R. This is transitive definition. So in this case, 1, 2, 2, 3 and also 1, 3 belongs to R. For this pair, transitive is true. What are the other possible pairs? What are the other possible pairs? 1, 3, 3, 3 and 1, 3 again belongs to R. So R is transitive with respect to this also. Next, 1, 2, 2, 2. 1, 2, 2, 2 belongs to R implies 1, 2 also belongs to R. Any other possibility? Any other possibility? 2, 3, 3, 3. So 2, 3 again belongs to R. Therefore, R is transitive. So R is reflexive, R is not symmetric, and R is transitive. Now take the options. R is reflexive but not symmetric. So clearly R is reflexive but not symmetric. Second option, R is reflexive but not transitive, but R is transitive, we have proved. So second option is not correct. What about C? Third option, symmetric and transitive, but R is not symmetric. Last option, neither symmetric nor transitive. It's not symmetric, but it is transitive. So this option is also not correct. So option A is the correct answer. It is reflexive, but not transitive. Thank you. Hi students, let us take this fifth question. Let R be an equivalence relation defined on a set containing 6 elements. The minimum number of ordered pairs that R should contain is option A 36, option B 64, option C 6. Option D is 12. So, R is an equivalence relation. Equivalence relation means it is R is symmetric. R is symmetric. R is also reflexive, and R is transitive also. That is the definition of equivalence relation. So, suppose let me take 6 elements: 1, 2, 3, 4, 5, 5, and 6. Okay, 1, 2, 3, 4, 5, and 6. Okay, so to be reflexive, R should contain to be reflexive, R should contain 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Correct? To be reflexive, you have to have this. Okay? Symmetric. You can take these 6 elements only. 1, 1 belongs to R, implies the ulta also true. Transitive, if you don't take such pair, that is AB, BC, then you have to assume it as transitive. Therefore, minimum number of elements required must be it's reflexive, it's symmetric. Since such pair is not there, therefore it is transitive also. So minimum number of elements required: 1, 2, 3, 4, 5, and 6. So option C, 6 is the correct option. If it satisfies symmetric condition and if it includes only those elements, then it is symmetric and transitive also. Therefore, if it satisfies reflexive condition, that is enough, the minimum number of elements. Therefore, option C, 6 is the correct answer. Thank you.